You ever just stop and think about the Map app on your phone? I mean, you pull this thing out of your pocket and boom, a tiny blue dot tells you exactly where you are on the entire planet. It feels like absolute magic, right? Well, it's actually one of the most brilliant bits of science we use every single day. So let's pull back the curtain and see how it really works.
So yeah, how does it do that? How can this little device in your hand pinpoint your location with such insane accuracy, whether you're in downtown Tokyo or on some remote hiking trail? You might think, oh, it's just using cell towers or Wi-Fi, right? Making a really good guess?
Well, the short answer is nope. It's not a guess, it's not an estimate, and it's definitely not magic. The reality is, your phone is doing some seriously fast math, all based on signals it's getting from space. And the key to that whole calculation is surprisingly simple. It all boils down to one single thing: time. That's it. That's the secret ingredient. Forget about complex maps or anything on the ground for a second. The entire global positioning system, the whole shebang, is built on the super precise measurement of time. Now, really, that's the fundamental idea. Your phone figures out where it is by basically acting like an incredibly advanced stopwatch. Everything else we're about to talk about just flows from this one simple principle. Okay, so if it's all about time, where's the clock? Well, it's not here on Earth. To get this, we have to look up, way, way up, into orbit. That's where the whole process gets started.
So what is GPS really? It stands for Global Positioning System. And what that means is there's this whole constellation of satellites, dozens of them, constantly circling the Earth. Think of them as clocks in the sky, and all they do 24/7 is beam radio signals down towards us. Now, what's packed into those signals is what's so cool. It's not a map, it's a message, and a very simple one at that. Each signal basically says two things. One, here's my exact position up here in space, and two, I'm sending this message at this exact time. And when I say exact, I mean it. These things have atomic clocks on board. All right, so satellites are screaming their position and the time down at us. How in the world does your phone turn that into something useful? This is where your phone's inner math geek comes out to play. So your phone's GPS receiver is always listening for these signals. When it catches one, it does something brilliant. It looks at the time the signal was sent, then looks at its own clock to see when it was received. It measures that tiny, tiny delay, the travel time. And from that little fraction of a second, it knows exactly how far away that satellite is. And the physics here is actually something you probably learned in school. Your phone knows the speed of the signal. That's the speed of light, a constant. And it just figured out the time it took for the signal to travel. You multiply speed by time, and you get distance. It's classic, simple physics happening in your pocket. But hold on. Knowing you're, say, 20,000 kilometers from one satellite doesn't really help. I mean, you could be anywhere on a giant sphere around that satellite. So how do we get from that massive sphere down to that little blue dot on the map? Right, so with just one satellite, all your phone knows is its distance from a single point in space. It's a start, but it doesn't tell you if you're in New York or Nairobi. Now, let's bring in a second satellite. Your phone does the same calculation for that one. So now you have two spheres of distance, and where they overlap, they create a perfect circle. Okay, we're getting warmer. Your location is somewhere on that circle. The third satellite is where the magic really happens for a 2D map. When your phone gets a signal from a third one, its distant sphere slices through that circle at exactly 2 points. The system is smart enough to discard the one that's, thousands of miles up in space, and bingo, it knows your latitude and longitude. But what about your height, your altitude? For a really precise 3D location, you need a fourth satellite. This fourth measurement locks in your position and also calculates your elevation. This is super important for airplanes, obviously, but it also helps your phone correct for tiny timing errors, making the whole system even more accurate. Here's a simple way to think about it. Imagine you're standing in a huge, empty field, blindfolded, and you have 3 friends spread out around you. If they all shout their name at the exact same time, you could figure out where you are just by hearing which sound got to you first, second, and third. GPS is just a ridiculously advanced version of that, using radio waves instead of sound. And this whole process has a name. It's called trilaterization. It's easy to confuse with triangulation, which uses angles, but trilaterization is all about using distances from known points, the satellites, to find an unknown point,
You. That's exactly what your phone is doing.
So we get the basic idea, but what makes it so mind-blowingly accurate? The difference between knowing your location within a few feet versus a few miles? Well, it all comes down to insane precision.
The accuracy is just a marvel of technology, really. You've got those atomic clocks in the satellites, which are accurate to within nanoseconds. Your phone is doing all this complicated math almost instantly, and the hardware can measure these microscopic differences in signal arrival times with incredible precision.
And to really get why this all matters, check this out. These signals travel at the speed of light. So if a system's timing is off by just 1/1,000,000th of a second, a single microsecond, your location would be wrong by 300 meters. That's 3 football fields. This is why that perfect timing isn't just a nice feature, it's everything.
So the next time you glance at your phone and see that little blue dot, just remember what's happening. It's this silent, lightning-fast conversation between your phone and at least 4 satellites way out in space. A conversation built entirely on time. Your location is not guessed, it's calculated. It's a tiny miracle of physics and engineering happening right there in your hand. Makes you wonder what other everyday magic is just brilliant science hiding in plain sight.